We're looking now at exponential functions. And first, let's take a look at ones we've already done. As the constant, looks like there's a misspelling there. The constant is a vertical or horizontal line, like y equals 3 that goes that way, x equals -4 goes vertically. The linear, constant, linear, quadratic, absolute value, and square root are ones that you've been used to already. So here now, linear ones like y equals mx plus b, you're used to seeing as diagonal lines with a y-intercept and a slope. And a quadratic, of course, is a parabola shape. An absolute value is a V shape. A square root has a starting point and a curve that's a very slow curve. And you have done all of these types of functions before. What is new now is this exponential function, which is y equals a times b to the x. So we have this b, which is a base number, and now the variable is in the exponent. A is just a number that changes the size of it or how fast or slow it grows. This type of function goes like this. Starts off small, or we go down to small. And then because as the exponent gets larger, the number gets bigger and bigger and bigger. Sort of like 10 to the first is 10, to the second is 100, to the third is 1,000, and then to the fourth would be, what, 6 of them, 1,000,000. So it keeps, or 100,000. Let's see, yep. Keeps on going up and up and up really fast. Now, from a table, you can determine if something is an exponential function. And the way, anyway, with any sets of numbers that you can tell, that there has to be, for the x's, a common difference. Let's spell that, difference. A common difference for the x's and a common ratio for the y's. A common difference means adding or subtracting it. A common ratio means multiplying, not dividing, but multiplying. So let's see in this first one here, from 0 to 2 is plus 2, from 2 to 4 is plus 2, 4 to 6 is plus 2, 6 to 8 is plus 2, 8 to 10 is plus 2. From 4 to 12 is times 3. 12 to 36 is also times 3. To get to 108, you multiply by 3. To get to 324 and 972, you multiply by 3 each time. So the common difference is 2, and the common ratio is 3. Because it's the same each time, or as an average for them, that means that this is exponential. All right, each time. So basically, it's a 2 over 3. Well, actually, no, we don't really do it that way. Just because there is a common amount, then each of those are same, and each of those are the same. Now, if we showed it from 0 to 4 and 4 to 36, that would be plus 4, and this would be times 9. So we could do that by doubling up those, but that 2 to 3 or squaring it 4 to 9 would be what each one of them are adding and squaring it. So there is a common difference and there is a common ratio. That means it is an exponential function. For this next one, we would look at it in doing the same way. We're adding 1, adding 1, adding 1, adding 1. From 4 to 2, it looks like dividing by 2, but you don't do it by dividing. It has to be multiplying, which means you're multiplying by half. And 2 times 1/2. 4 divided by 2. 4 times half, 2 times a half. Now we've got a problem. Wait a minute. 2 to a half, that doesn't do it. This one would be times 1/4. It's plus 1 and plus 1, but then this one's times a half, times a quarter, or let's say times 1/4 of it. From here to here is times 1/2. From here to here is times 1/2. This one's not common, it's not the same. So not an exponential function. Now let's see on the next one. Plus 1, plus 1, plus 1, plus 1. So I have a common difference of 1. Now here, if I do 1.6 times 1/4, oops, that goes half 1 and that's 1/4. So that's times 1/4. 0.4 to 0.01 is also times 1/4. Let's check each one of them now. This is times 1/4, or 0.25. This one's times 1/4, or 0.25. So there is a common ratio, and it's 1/4. Okay. Let me put boxes around these, and yellow around them too. So this is one skill that's important for you to have, is to recognize common difference and common ratio, or when it's not possible because they're not the same difference in ratio or the same connection between them. Okay. So we determine this one is a polynomial function with a common difference and a common ratio. We're going to graph one of these now. The safest way to do this without simply putting in a graphing calculator would be an XY table. Even if you do use a graphing calculator, I insist on seeing an XY table. Now, we know that usually these go like this. Okay, that's usually what the exponential function looks like. Okay, do that. This one is usually considered a parent function. So what we're going to do is let's pick a few numbers from lower to higher. I'm going to go from like -3, -2, -1, 0, 1, 2, and 3. So what I get, if you put a 0 here, 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. 2 to the third is 8. But when we go to a -1, well, let's do this. 2 to the -3 is equal to 1 over 2 to the third is equal to 1/8. This one, -2, if you put that in there, you get 1 over 2 squared, or 1/4. And this one's 1/2. Now we're going to attempt to graph that. 0 and 1, -1.5. So I've got really small numbers there. And then I have 0, 1, 1 and 2, 2 and 4, 3 and, I put a 3 here. And 2 to the third power is 2 times 2 times 2, which is 8. 3, 4, 5, 6, 7, and 8. So I have a curve that's going up pretty fast here. And then this one hugs along essentially the river there, but does not actually touch it. So that's the basic graph here. Let's do the same thing with a little change where the B number is 1/3. So I'm going to do an XY table. And I'm going to do the same, -3, -2, -1, 0, 1, and 2, and 3. So if I put -3 in here, 2 to the 1/3, -3, the negative makes you switch what's inside. 2 over 1 to the third power. Now I can do 2 to the third power, so that's equal to 2. 2 to the third is 8. Let's see, that would be 16. Let me verify what I'm doing here. Would I put it in -3? Aha. That's supposed to be a 3 here, so that's my mistake. There's a 3 here. The negative allows me to switch that inside, so it's 3 over 1. 3 cubed, 3 times 3 times 3 is 27, which means 2 times 27 is 54. So that's 54. I can do the same thing with the other numbers, putting them in, but recognizing that means that a fraction there, because of the negative, becomes not a fraction when we take the negative away. Now, here are the rest of the numbers on here, so to save time, I'll show you the ones that they are. 6, 0, 2. And this one's 2/3. This one's 0.22. And this one's 0.07 or 0.1. So close to 0.1 would be. Now, I'm going to graph those points. This one's too far to graph, and that one's too far to graph, but the others are not. So -1 and 6 for 1, 2, 3, 4. Let's see. I'm doing this one here. 1, 2, 3, 4, 5, 6. There's the point. 0 and 2. 1 and 2/3. A little bit less than 1. 2 and 0.2, which is very close to ending this. 3 is almost just a small amount. So that means the curve goes this way this time. There. So that's how this type is done. The remaining problems are good practice problems. So we'll continue to go through them. But you might want to stop and do it if you can. Pause when I get to new one, try to do one for the XY table. And I'll do the same. Well, this time 3, 2, 1, 0, -1, -2, -3. And I'm going to put each of these into here. But now with something like this first one, y equals 3, 2 to the 6th power. So that means oh no, that's meant to be 3 then. So this is a 3. 2 cubed is 8. That's 3 times 8, which is 24. So that's, if I put a 3 in there, I get back to 24. Too much on the graph, but still. Now, if I do a 2 in here, that's 4 times 3, that's 12. And if I put a 1, it's 6, and a 0 is 3. And at -1, we have a 1.5. At 2, it's about a -2. Well, didn't mean to put that one. It's about 3/4 of a dollar. So negative 2, 1.5. Oh, not 2. So this one comes to 0.75. And I hadn't done the 3, but -3. Let's try it, because we have 3 times 2 to the -3rd power, which is 3 over 2 to the 3rd power, which is 3/8. Okay, which is about 0.4. A little less than that, but that's good enough. This one's too much. The 2 and 12 is almost too much. 1, 2, 3, 4, 5, 6, 7, 9, 10. So if I'm going to go to 2, I'm going to go a little bit above it. The deal above it. 1 is 6, 0 and 3, -1 and 1.5, -2 and now 2 3/4 about. Let's see, about there. And -3 is just over the 0. So we have this kind of a curve, but instead of it going through 0 and 1, it goes through 0, 3. Because that's what that number does to help it. There, we just wrapped that one. Now let's do one with a couple of fractions on it. The process is still going to be the same. I'm going to do an XY table. This time I'm just going to use 2s. So from there, 2, 1, 0, -1, -2. So here, if that's a 2, I get 5/6 times 1/25. We can now square it, that becomes a 5. So that's 1/30. Well, that's a really tiny decimal. It's about 0.1. If I put a 1 in there, I get 1/6. Because with a x equals 1, this is the same. Then we multiply them, we get 5/30. Or if we separate and realize why we had it, we read, well, we just multiply there because 5 and 5 cancel out. But that's because there's only one of them. Now, if I put it to the 0, 5 to the 6th times 1 to the 5th to the 0, it's only this one is affected. So that means it's 5/6, which is about 5/6, which is approximately 0.9. If I put a -1 in and switch it, okay, so I get 5/6, and a -1 exponent will make it 5/1, so it's 30/6. And that actually makes it about, oh, 1 minute. Oh, not 30. Oh, 1 minute. 5 and 1, 25/6. Yep, we're at 25/6. See if I can get this right better. If I switch it around my hand. 25/6, so which is about 4.2. And if I put -2 in there, I get 20.8. So let's round these and get it close to there. 2 is barely above ground there. 1 is 1/6. That's also still barely above ground. 0.9 is just a little bit below it. And -2, oh, -1 and 4.2. Yeah. -2 is 20 something. Oh, that's way up there. Yeah, back. Okay, there's a not quite correct, but approximation of it. So the fact that both fractions doesn't really change any methods that you use. It's still pretty much the same type of thing. All right, now let's look at a last couple of practice ones here. Okay, let's look at these. I'm going to do the same XY table, and I can do 3s to -3s or 2, 1, 0, -1, -2. I think I'll stick with those here now. So I put a 2 in there, that makes it 9 times 5, and we have a 45. Okay, let's see, right now, 5 times 3 to the 2nd power is 5 times 9, which is 45. If I put a 1 in there, I get a 15. If I put 0 here, we're going to get a 5. Okay, 3 to the 0 is 1. If I put -1, we're going to get 5/3. Wait a minute, let me think here. If I put -1 the x, it's 5 times 3 to the -1. That just makes it 5 to the 3rd. Okay, so that's 1 2/3. Let's get this solo show. Okay. And for -2, that would be 3 squared. Well, that would be 5 times 3 to the 2, or 5 over 9, which is about 0.6 or so. Okay, now let's graph these over here. 2 and 45 we can't. 1 and 15 we really can't either. But we can do 0 and 5 and extrapolate up really fast when we draw one. -1 and 1, between 1 and 2. Okay, maybe he'll, okay, let's just do that one. -1 and 2/3 is close to the -2. -2 and 0.6 is only slightly above halfway down here, that point. But we now have enough to be able to graph these. Oops, if it'll stay on here. There, now that one's graphed on here. I could have done that by graphing by 2's also. Okay. Now graph an exponential function where we have the half like that there, and then the 3 on the outside of it. So I'm going to do 2, 1, 0, -1, -2. So let's start with the 0. If that's 0, that's just 1. 1 times 3 is 3. And if it's 1, then it's 1/2 of 3, or 1.5. So for 2, y is equal to, well, if that's 2, that's 1 squared, and 2 to the second, which is 4. And that's on the bottom. So 0.75. Now when I go the other way with the minus, the -1 here will make us switch it. 3 times 2, therefore, is 6. And then -2 will square it. So instead of 4, it's 2. And then this is 12. Okay, let's graph those particular points. 2 and not quite 1, 0.75. 1 and 1.5. 0 and 3. -1 and 6. And -2 and 12 is going to be up there somewhere. On there. And there we have graphed that exponential function. And that actually ends it. These are good practice ones. So you can see just doing a table and knowing that the shape is going to be in this form somehow. It could actually be flipped, rotated, or other things. All right, so these are all good examples. And remember, especially here for these tables, to find a common difference and a common ratio every time. Thank you for listening. I hope this helps.